Hello, we're looking at learning target D using the Pythagorean theorem to solve real-world problems. One of the most important things to remember is that the Pythagorean theorem works for right triangles. So the first statement you see at the top of your paper here says that if a triangle is right, then a squared plus b squared equals c squared. Important to note that a and b are legs, c is the hypotenuse. And so we need to identify those things as we go. So let's go ahead and take a look at the first example. First example, we have a shuffleboard. We've got two dimensions in the shuffleboard, and we are going to try to find the diagonal from one corner to the other. And anytime we've got a real life example, I like to just pull out the information that is necessary. So on my picture here, I'm going to draw the triangle. All right, and I know that I've got 154 on this side is 20, and I'm trying to find x, or any variable for that matter. Well, I like to draw the triangle then and pull those measurements, 154 and 20. There's a 90-degree angle, and this is x. I think it's easier if we kind of eliminate distractions and we just look at the measurements given. Now I want to identify the hypotenuse. It's always across from the 90, so I will say this is the hypotenuse, leaving me with a leg and a leg over here. And now I can use the Pythagorean theorem to help me solve. So I will say 154 squared plus 20 squared equals x squared. On your calculator, you will enter these two things and we have an equal sign. So I'll put a line down my equal sign here. I can add 154 squared plus 20 squared on my calculator, and I can type those in together. So 154 squared plus 20 squared is 16, and equals x squared still on this side. And in order to get rid of a square, we need to undo that square by taking a square root. So once we take the square root, we will be left with x on this side, and equals to the square root of that number is 155.29. This problem asks us to round to the nearest inch. Okay, nearest inch. So I would say that this 9 pushes it up to a 3, but the 3 does not change this 5, so we will leave it at 155 inches. Example 1. Right, example 2 is a similar question. The triangle is labeled for you in this picture. We are trying to find the distance across this pond. It's a tough thing to measure, so we've set up a triangle outside of it. I'm going to put a variable here. Let's choose a different variable, perhaps y this time. And the triangle is already drawn for you, but I will pull the triangle out again. Okay, because we want to try to eliminate any distractions or any information that is just not necessary. So I've got 18 on this side, I've got a 28 on this side, and I've got a 90-degree angle down here, and my unknown side length is y. And again, I think it's very important every single time, identify the 90 across from the 90 is the hypotenuse. This automatically then becomes a leg and a leg over here, and we can set up the Pythagorean theorem. 18 squared plus 28 squared equals y squared. And once again, we've got an equal sign down the middle here, and we can add 18 squared plus 28 squared on our calculator. That totals up to 1,108. is equal to y squared. And to undo a square, we need to use a square root. So I will take and I will square root both sides, leaving me with y is equal to 33.28. And again, this asks us to round to the nearest foot. Previous one was inches, but we're still going to round to the ones place here. The 8 does push the 2 up to a 3, but the 3 will not change to the 33, and so our final answer is 33 feet. 33 feet across. It's always easy to kind of judge if your answer is correct. Does that make sense looking back at the picture? You know, we've got lengths of 18 and 28. Of course, the hypotenuse is going to be the longest side. So we know that we expect something longer than 28. And so 33, of course, fits into that. If you get an answer like 1,000, probably something went wrong here. That just wouldn't make sense for the picture that we're shown. So you can assume that the picture is going to have some relevant information after to check your answer. All right. The last question is going to be a little bit different, but we're going to set it up exactly the same. I'm going to draw my right triangle in to the picture, right on the picture, and then again I will pull out just the information that I need. I've got a 30 as my height for this telephone tower, and our unknown side length here is x. Okay, and the length of this guy wire, the thing that kind of holds it up, is a length of 39. Now when I pull this triangle and I just look at the information that is necessary, here's my 90-degree angle, here's x down here, here's 30, and then here's a 39. We see that now the hypotenuse is known. We have this measure. This is our hypotenuse. The 2 over here are our legs. We'll just mark those with an L, and this is going to change our Pythagorean theorem a little bit because now our variable is going to be on the left side of the equal sign. We're going to say 30 squared plus x squared equals 39 squared. So each problem is unique, and you have to kind of go into it and make sure that you check which is the hypotenuse, which is the leg. So we're going to have to solve this one a little bit different. I'll still put my line down the equal sign, but now I'm going to actually just write the answers to these. 30 squared is 900. I don't know x squared yet, so I'll just leave it as plus x squared. And 39 squared is 1,521. And just like solving anything, we are trying to get the variable by itself. So we want to subtract 900 from both sides. On our left side of the equal sign, we still have x squared. That 900 canceled out. Over here we have 621. And now in order to get rid of the square, we will take the square root of both sides. And so x will equal the square root of 621, which is 24.91. And again, it asks us to round to the nearest foot, so that's talking about this place right there, the 4. Looking at this 1, that doesn't change the 9, but the 9 does tell us to round up, so we will round this to 25 feet. So most importantly, we want to make sure that we're always identifying which one is the hypotenuse and the 2 legs, because where you put the numbers in the Pythagorean theorem does matter. And so each situation is a little bit unique.